Everybody, welcome back. I hope you had a wonderful week. In this tutorial, I'm going to show you how to build a Python dashboard with multiple Excel sheets that you can just drag and just create. So for example, we have these three Excel sheets, well, two CSV sheets and one Excel sheet. We'll drag into here and it automatically creates a data table and a graph right under it. 1, 2, 3. And you can actually play around with the data table and the graph by filtering, by choosing columns. Here I want to see all the snow months above 50 centimeters, so you can see how the graph changes. And here I can change also from methane to CO2. I can filter the months only to see the November month, and so on and so on. So this is really cool because it's very useful if you have the same Excel sheet that you're using over and over again. You can definitely build an app just like this. And this is only with Python and Dash. So if you have an Excel sheet, or 2 or 3 or 5 Excel sheets, where the header names are always going to stay the same, and you're only changing data, you're only updating more and more data and adding more rows to it, then you can build an app just like this that is based around those 3 different Excel sheets or CSV sheets. So this is how we do it. Go to my GitHub. Don't forget to fork it, star it if you want. And then it's inside the analytic web apps, multiple Excel dashboard. And this is everything you need for this tutorial. I would recommend to go into here and download this or copy this into your computer so it's easier for you to work with and follow along. I'll have the link under the video as well. So let's go to the code and open up this PyCharm and open up this code. Now all the code is right here. It looks long, 140 something lines of code, but don't worry about it, because really all you need to know is this part right here from 103 to 141. This is where we're going to spend most of the tutorial, and this is the most important part because this is what builds the graphs. All the rest, all of this right here, is pretty much something that you can just copy paste into your own code and just reuse over and over again for your data tables and your Excel sheets. So let's go over this section right here for the first couple of minutes, and then we'll dive right into the most important part of the app. Okay, so as you can see, we have this app where the layout right here is a div where we have a title, dashboard of multiple right here, Excel sheets, and then we have an upload component, DCC-core component upload, which is this one right here, where you can select files or you can upload files into it, just drag and drop. And then we have an empty div. This output data upload, here you don't have anything, this is empty. So if we actually take out, hashtag out everything else, you'll see that when we start the app, you will only have a title and an upload component, right? But we want more than that. We want to have this section right here. We want to insert into this div, which is right under the, it's right here. Insert into this div the data tables and the empty graphs. And this is what we do with this callback right here from line 36 to line 101. We're using this callback. No need to go into this right now. But the most important thing you need to know from this long function, again, just copy paste it into your computer. You can reuse this. The most important thing to know is that it's looking to see if the file that you're uploading, as soon as you upload this climate change file, let's upload both climate change and NYC snow. As soon as you upload, it's going to look to see if the file has a CSV ending to it, and if it does, then it will use a pandas read CSV method. If it has an Excel or XLS ending to it, it will use the pandas read Excel method to create the pandas data frame. And once we have the pandas data frame, we can create the tables and the empty graphs. So here we're creating this data table with the data frame that we pulled from this Excel sheet. So the first one is the climate change CSV Excel sheet, this one right here. So this is the climate change data, and then we're creating only five rows. You can only see 5 rows in the first page, and you can always go more, but it's only 5 at the beginning. And then you can do filter action native. You can actually filter right here, right, over 350 and so on and so on. You can column select single if it's the 2 CSV sheets. So you can have the column selectable, you can see here. And then we're just giving an ID. The ID is a pattern matching ID, because you don't know if the user uploaded 1 CSV sheet or 2 CSV sheets or 10 CSV sheets. So we're going to give it the index I, which comes from here, for the first for the first file. This will be 0, then 1, then 2, right? So I, and the same with the graph, the index will be I, the index will be 0. So for the first table and graph, the index will be 0. Let's actually hashtag this second callback out, so you can see only this first callback that is returning an empty graph and a data table with the data, nothing else. So if we go back, and we'll grab these 3 CSV and Excel sheets, we'll see we're only creating a data table and empty graph. Data table, empty graph, data table, empty graph. This first data table is the climate change. It's not always the same order, but here it is. So it's the climate change data. This index will be 0, and this graph will be 0. Second one is a Toronto temperature data. So this table will be index 1, and this graph will be index 1 right here underneath. And then so on with number 3 or number 4 or 5, however many Excel sheets you want. Okay, so we have our table and we have our graph. So now let's bring back the callback, the last callback. Let's close this just so we don't have to see it the whole time. And let's focus on this callback right here from 103 to 140, because this is the main callback where it builds the graph from the filtered data in the data table. All right, let's reload. Let's just put 2 graphs in there instead of 3. You can also do 1. And now we see that we have 2 graphs. The climate change graph and the New York City snow measurements graph, or precipitation. So what we're doing here is, this is pattern matching callback. You can read more about it in the dash documentation, pattern matching. I also have another video on pattern matching callback that I think you can see up here to the right. But the pattern matching is used in these cases where we don't know if the user is going to upload 1 data table, 2 data tables, 3 data tables. We don't know, right? So it's dynamic. You can upload as many Excel sheets as you want, with limitations to the amount of data. Probably more than 100 megabyte will be a little bit slower. So all of these inputs that trigger the callback and the state, right? All these arguments here are referring to the properties, 3 properties of a certain data table. It could be the first data table, it could be the second or the third. It depends on what data is being used, right? So let's try to understand this a little bit better. The first argument, the input, is a derived virtual indices, right? So this is you can actually print it out and see what it gives you. This is the filtered data. What data is actually being filtered. If I click on the first one, I'm going to filter the first one. Let's filter this, only equal to month 10. You'll see that it's given me an output only of this data table, the filtered indices. These are the rows that are left inside the data table after I filtered it. You see 6 times 5, about 30 different rows, right? So this is a filter data of this data table because we just interacted with it. This will represent the selected column. So let's actually print out the selected column so you can see. Because this refers to this right here, right? This is the argument. Let's reload it. All right, so if you can see, we select the column here of CO2. This is a climate change data. So you can see here, if we go all the way down, print selected column, CO2. You see, you just printed that. If we select a different one, let's select the methane, CH4. You'll see that here we have CH4, right? So it automatically knows what data table you are interacting with by using these inputs, right? But only when you filter the data table or when you select a column, this callback will be triggered and build the graph and return the graph. We also need all the data in order to We're going to need all the data in order to read, to filter the data with the indices. So this is the most important part. Listen carefully. If we go here and we upload this, now what we're going to do here is if we filter this, I don't know, equals 5, you see how the graph changed a little bit? What we're doing here is we're saying take all the data and build a data frame, a DFF, but then filter the data frame or reduce the amount of rows so it only includes the rows from the filtered data. Remember the indices. Only those rows that are filtered, include them into the data frame. So now we have a reduced data frame, and what we're going to do now is we're going to say if the first column of the data frame equals year, then do something. Because we're going to actually build the graph and return the graph, because we don't exactly know what data frame we're actually interacting with. So in this case, the first column of this data is year, then we are going to do all of this. If the first column of the data frame is station, as you can see here, where is station? Oh, station we don't have. Station is in the other Excel sheet. The first column is equal to date time, then you can do this. Then we know it's this data frame, and then we're going to do all of this grouping and creating of the figure. So let's see an example. In this case, if I'm going to interact with this data, let's do, I don't know, month, let's do rain over 10 millimeters. Whoops, has to be over, not question mark. If rain over 10 millimeters, we'll have, for those months and those years, we'll have a new graph that is being created. So how is it being created? If you go in here and you see that the first column of the data frame equals date time, which it is because this is date time, then do something. This first column is not equal to station and it's not equal to year because we did not touch that data table. We touched this data table. Then we'll just group by year, take all these minimum, max, and mean temperature, just take the mean of it, reset the index, and build the line chart that we're building right here, right? And then return this figure into the output, into the figure property of the matching index. So this is all happening behind the scenes. So this will return to the index that matches the index of the data table right here. If you open this, you'll see the same index, right? So it will return to the same location of this graph. That's why it's returning down here the graph and not into here or not into the first one, right? Just down here. Let's do one last example. If we will interact with this data table, let's look at column chosen temperature difference over the years. Unfilter this. Look at temperature difference. You'll know, the app will know that you're interacting with this part of the data because the first column of this data frame is year, right? You just triggered the callback because you selected a column. See, we selected a column, The callback is triggered. You filter the data frame because there's only one data frame that we're interacting with, but we're telling the app that if it's the year data frame, the one with the first column equals year, then start doing something. Print the data frame head, group by year, choose a selected column, do an average of it, and then create the line chart and return the figure into the same corresponding figure index, right? The only difference here is that if the selected column equals year, if we actually selected column year like this, don't do anything. You see, it didn't update. This updates, but this does not update, because if you would update the graph, you would group by year and then do an average of year as well, it will throw an error. So it doesn't make sense to choose year, because on the y-axis you just want these columns. You don't want the year and the y-axis to be the same. So that's why we put here no update, or else just do all of this. Okay, so this is a pattern matching callback, and this is a great way to build a Dash app if you have Excel sheets that you're using over and over again, where the column headers are not changing. Only the data is being added or removed. If you have any questions, definitely under the video, ask comments, use the comment section to ask any questions. I would also say, if you're doing this with your Excel sheet, then start small, start little. Like erase all of this and just do one Excel sheet, just do one of these, put the first column name that you have in your Excel sheet, and then maybe even do a simpler, don't do group by, just do a simpler PX line with the same X with a certain Y value, and just show the figure. Just show that it works. The only thing you need to do is work slowly, and if you have any questions, definitely under the video or go to the Plotly forum and ask the questions there. People are very, very helpful. So thank you very much. I hope you enjoyed this video. If you did, you can always support me on YouTube, or if you want to show some love on Patreon, you can also go in there. I have some tips and tricks in there as well. Thanks for watching. I hope you had a wonderful day, and always remember, we are better together, so help each other out.